Hello, this is the lesson from the first day of school. This is Unit 1, Lesson number 1, Day 1. We started today with just some preliminary stuff. You had to pick up some materials. Those materials are on Schoology, or you can see me if you were absent from class. And then I gave you seats and we took attendance. Again, you can see me if you were absent. But then we went ahead and we got started here on the lesson, which is what I'm going to do now. I did talk about in class some information about the homework. So whenever the homework assignment on the calendar says pages, that's referring to the unit packet. And if it were to say worksheet number, that's referring to the worksheets booklet, which is orange. So just to let you know that. But homework for tonight, you are going to do pages 1 and 2. You're going to get those supplies. You're going to study for next week's summer packet quiz. And you have a little quiz tomorrow, which is a time factoring quiz. It's 8 minutes and there's 10 questions, and you're going to read through all the information in that yellow course information sheet, and you're going to get that filled out by Friday. So that takes care of the preliminary stuff regarding the course itself. Then we went ahead and we got started with the lessons. So the first thing I had students do in class today was write down this warm-up in their notebook and then try it, attempt it. So if you weren't in class and you're copying down these notes, go ahead and copy this down, and then you should pause the video and try to do the warm-up problem on your own first, then play to check your answers. Okay, so now that you've had a little bit of time to work on that, you pause the video. Let's go ahead and go over it. So there's the answer to the warm-up. First, you needed to use the slope formula to find the slope, which I did. This is our slope formula here. And then I used that slope formula to find the slope, which was 4/3. Then I used slope-intercept form. If you remember from Algebra 1, point slope form, you can also use point slope form. Either will work. I chose to just use slope-intercept form, and I substituted in the slope 4/3. I picked one of the 2 points, which I just used 1, 2, substituted in for x and for y, solved for b. 2 in thirds is 6/3, so subtracted 4/3 from 6/3 and got 2/3 for b, which means my equation is y equals 4/3 x plus 2/3. Again, had you used point slope form, you would get the same answer, just you'd have to do one more step, because once you had y minus whatever value you had there for y1, either 6 or 2, you would then have to add that to both sides to get it into slope-intercept form. So either just use slope-intercept form from the very start and it'll end up being in slope-intercept form, or use point slope but then get it into slope-intercept form. Either's fine. I don't really care which technique you use. Now, I did mention to students in class that this is one of the topics that's in the summer packet, so you should know how to do this for next week's quiz on the summer packet. Check the date on your calendar or Schoology for when that quiz is. Okay, next I did go over some things in Schoology, so where the calendar is located, the unit folders, and the videos of the lessons. I'm not going to really do that here. If you have any questions on Schoology, please see me about that, but I will just point out here that every lesson is stored, a video of that lesson is stored in Schoology, and if you're watching this, then clearly you found it. But anytime you're absent, you can go on Schoology, find the lesson based on that date, and then watch the video of that lesson. And if you're absent, you should do that. Okay, so then we got into some notes for Unit 1. So again, if you weren't in class and you're watching this video, you should copy down this diagram, these notes. Now, this material is review, but it's probably been a while since you've used some of these terms, so you may have forgotten them. So you're going to copy this diagram, And we started, when I explained this diagram, I started over here on the right in this small set, which notice is not part of this big set of numbers. And that set, you probably have not really dealt with a whole lot yet in your previous math classes. It's called the set of imaginary numbers. So what are imaginary numbers? Well, first of all, what they look like. Square root of a negative, that's considered an imaginary number. What you need to know about it is not only what it looks like, square root of a negative, but the fact that it's not part of the set of real numbers. So it's not considered a real number, it's considered an imaginary number. Also, I is actually a number, not a letter, in math class at least. And so if you see something involving I, like I, or 2 times I, or 2 plus I, those would all be examples of imaginary numbers. Again, not part of the set of real numbers. So then we have, besides the imaginary, we have this big set of numbers called the real numbers. And anything in this set of real numbers are considered real. So we're going to start on the very inside here with the numbers 1, 2, 3, 4, so forth. You learned, when you first learned to count, you learned about those types of numbers. At one point, they were called counting numbers, and then at some point, you should have learned the more mathematically precise name for them. Numbers 1, 2, 3, 4, so forth are called the natural numbers. So notice that set is part of the real numbers. It's a subset, so that means that natural numbers are real numbers. Now, we have another set that includes all those natural numbers, 1, 2, 3, 4, so forth, but we've added 0 into the set as well. So this set of numbers includes all of the other numbers we talked about, the natural numbers, because natural numbers are a subset of this set. This set of numbers, when we include 0, those are called whole numbers. Okay. So all natural numbers are whole numbers, but not all whole numbers are natural numbers. So hopefully you see how that diagram works. Now we have the whole numbers, 0, 1, 2, 3, but we've included the negatives as well. That set of numbers is called the integers. Okay. So all whole numbers are integers, but not all integers are whole numbers. Okay. Next, we have still included all of the integers, 0, positive, 1, 2, 3, and negative 1, 2, 3, and so forth. But now we've added fractions into the mix and decimals. Now, with the fractions and decimals, pay close attention. The fractions, if I change them into decimals, notice they either terminate, like 1/2 is 0.5, that terminates, that ends, or if it repeats, like 2/3, 2/3 is 0.6 repeating, 0.2 repeating. If it does not terminate, like 0.5 does, if it is non-terminating, there has to be a pattern, and the pattern has to be repeating. Okay, so like 2/3, like 0.222, it's non-terminating, but the pattern is repeating. That set of numbers, those are called the rational numbers. Okay, and I will use this terminology very often, which is why we're reviewing it. Now, we're still part of the real number set, but notice this is separate from all of these sets. So these numbers, like pi is non-terminating. It doesn't end, but it also is non-repeating. There's no pattern to it. There's nothing that repeats. Square root of 2, non-terminating, non-repeating. There's no pattern that repeats. Those numbers are irrational. Okay, irrational numbers, again, are still real numbers. They're not imaginary, but their decimals don't end and don't repeat. There's no pattern that repeats. Versus over here, the decimals either end, they're terminating, or if they're non-terminating, there's a pattern to the repeating. Okay, so that's your set of real numbers and imaginary numbers. We used that set to answer some questions here. So first of all, if you weren't in class, you're going to copy these down into your notes, and then I'd like you to answer them. Is this true or is it false? And if it's false, you're going to rewrite it to make it true. So the first one, the square root of 4 is an irrational number. Well, first of all, the square root of 4 we know is 2. And 2, is it an irrational number? Well, that's false. Square root of 4 is not irrational, okay? Now you don't want to put not in front to make it true. So I'm just going to get rid of ir and make it a. Now it's true. The square root of 4 is a rational number. That's one way to fix it. Okay. Next, we have the square root of 3 is a real number. And is that true or false? Well, the square root of 3 is a real number. That is true. All natural numbers are rational numbers. That is true. Everything that's in the list of natural is in the list of rational. So that's true. Number 4, all whole numbers are natural numbers. That is false. All whole numbers are natural numbers is not necessarily true. So what could I do to make it true? There's a couple different things. Probably the easiest would be to change whole and natural and flip them around. All natural numbers are whole numbers. Now that's a true statement. There's a couple other ways you could fix that, but that's one way to do it. Okay, that takes care of today's lesson. Again, most of today was really just getting to know me getting to know you, and talking about some of the policies and things like that, which if you miss class, you can come and see me and get those papers and hear about those different items. Reminder, you do have a time factoring quiz tomorrow. To prepare for that, you should look at the summer packet and the section on factoring and make sure that you can do all of those problems and in a reasonably quick manner. You're going to have 10 problems in 8 minutes on tomorrow's time factoring quiz. Next week on Tuesday, or again, that could vary depending on schedule, but check Schoology for the date. Next week, you'll have a summer packet quiz. And the yellow paper with the course information, you're going to read through all that, get it filled out, get it signed, fill out your part, and that's due at the end of this week. And I believe that is it.